The straight line passes through the points A, -1, -1, and B, 5, 9. I'm actually going to call this one x1, y1, and this one x2, y2 here, so that there's no confusion when I come to use this point later. So the first thing we need is the gradient, which is the difference in the y's, y2 minus y1, over x2 minus x1, the difference in the x's. So that's -1 take away 9 over -1 take away 5. So that's -10 over -6, which is 10 over 6, or if you like, 5 over 3. So now I'll use y minus y1 is equal to m x minus x1. So that's y take away 9 is equal to 5 over 3 x take away 5. Now if we multiply both sides by 3, that will give us 3 y take away 9 is 5 x take away 5. So you can see what's happened there. The 3 from here just comes up in front and multiplies. So 3y minus 27 is equal to 5x minus 25. So 5x, bring the 3y over to be with the 5x, minus 3y. So those have gone to this side. Now bring the -25 over this side. -27 plus 25 is -2. And then we have general form. So we want the distance now between the points A and B. We could use the distance formula, but at the end of the day we're just using Pythagoras here. So this point here is -1, -1, and this point here is 5, 9. So we're just going to form a right angled triangle here. And going -1 across to 5 is 6 across. -1 up to 9 is going 10 up. So if we call this d, d squared is going to be 10 squared plus 6 squared. So d squared is 100 add 36. So d squared is 136. And therefore d is the square root of 136. So we want the square root of 136. So that's 11.66 if we go to 2 decimal places. And now we want the midpoint of the line segment, in other words, the point that's exactly in the middle of this line segment here. Now to get that, we average the x-coordinates, so the x-coordinates are -1 and 5, add them together, divide by 2. And we do the same with the y-coordinates, so -1 add 9 divided by 2. So that's 4 divided by 2, which is 2, and 8 divided by 2, which is 4.